Hello everyone, it's June the 10th. Alright, let's go right into it. I feel thirsty today. I don't know why. Alright, this is the challenge. Minimum operation to reduce x to 0. Done this before. You give an integer array and an integer x. In one operation, it can either remove the leftmost or the rightmost element from the array and subtracts its value from x. This modifies the array minimum number of operations to reduce x to exactly 0 if it is possible, otherwise return -1. So we can do 3 and 2. This is not possible. 5, which would be 1, 2, 3, 4, 5. Yes. Okay. What's your opinion? Basically, we're trying to see the minimum number of numbers on both sides that we can take and need to have them add up to 5, add up to x. Well, what we can say is for each number, right, there's always an option of whether you take it or you don't take it. Right, let's take the first one. 1, 1, 4, 2, 3. Right. So you either take the leftmost or you take the rightmost. And we'll want to add up to 5. And what's the length? 10 to the 5th. So we can say if we take the leftmost, right, then it's the remaining number with x with 4, right? The remaining number with 4. We can also take the rightmost, it's the remaining number with 2. Or we can take, you either take the left or you take the right, but you cannot not take it, right? Each step you have to take one number, right? So it's either take left or take right. So if I take left, then we have 1, 4, 2, 3. We have to get to 4, right? If we take right, we have 1, 1, 4, 2. We need to get to 2. And then we're going to take a left again. Now, this example is -1 is immediate because we have nowhere to take. So basically, if it's smaller than the x, then we can try to take. If it's bigger, then we cannot take. Okay, so we take from one side, and the remaining. Are all the values larger than 0? Yep. So I can produce a reduced list. I mean, X is huge, but we can try just go from left to right, keep adding until we get to the value. So we have a list of number from left to right. Right, I don't have a list of number from right to left. They might intersect though. Which is fine. We can just keep going. Like if we hit the end and then we cannot reach, then yeah, if we add everything up and then we cannot reach, then it's not possible. Hold on. If we flip the whole thing, 11423, and then we append 11423 to the end of 11423, then the problem is finding the shortest subarray, right? The shortest subarray that adds up to the x. Shortest subarray that starts from the front or it extends, so it cannot be in the middle, right? So either starts from the front or we have to cover, like must end at 3. Not must end, it must cover 3. Right, either start from the front, so we can just go start from front, we find a solution, which in this case we don't have solution start from front, because 114 is 6, so we don't have, so we have to, if we want to succeed, we have to involve 3, right? So basically, we want a subarray that includes 3 that add up to 5. So what do we do? Why don't we just do can we do a cumulative sum? 1, 2, 6, 8, 11, 12, 13, and 17. And we want to find out, right? We want to find out x, 5. And then for each one, we just minus 5, right? So for 6, if we can find 1, but okay, so in this case, we go front to back. So we'll go from first as 1, 2, 6, and then now we don't find 5, so that's a no-go. So it has to be either all at the back or front. So we have to involve the 3, so we have to involve this 8. So now we just need to find something that so we can go, I don't know, 8. Yeah, I have to start from 8 because it has to include 8. Either something to 3, right? That's the minimum requirement. Something beyond 3. So 8 minus 5 is 3. 3 is not in there. 11 is minus 5 is 6. We have one. So basically, what we're saying is no, wait, hold on. 3 is 11. So we start from here. So 11 minus 5, 6. Oh, we have, right? So we binary search. Now we get it. Okay, we have 2. Now we go have 12. 12 minus 5 is 7. We don't have. 13 minus 5 is 8. We have, but now we have 3. And 17 minus 5. 17 minus 5. Now it has to involve it has to involve 3. So 17 minus 5 is going to be 12. But 12 doesn't involve 11, so that's no good. So eventually it's 2. I think this holds water. I think this will hold water. Let's see. So about 10 minutes. I think 10 minutes we had a general idea how this one goes. Oopsie doozy. Yesterday 10. Oh shoot. Yesterday was 10. Ay. Oh, I think I got it wrong yesterday. One of the day was wrong. Yeah, it should be 11. All right, so the idea is, 10 to the 5th. You add a 10 to the 5th. How do we do that? I guess it's fine. It's just 2 times 10 to the 5th. So it's not that preposterous, right? It's not that preposterous. Let me bisect right. Okay. It's not that preposterous. Muito say new nums. Right? Nums plus nums. We actually don't need to do that. We don't need to do that. We'll just add a 1 by 1. Alright, so we first are going to try to find if we can do from front. Basically, what we need is it's a tool, support, accumulate. I'm going to do the accumulate. Alright, we're going to say pre-sum equals list accumulate nums. Right? And then I'm going to say rest is going to equal to, I don't know, math.inf. I like to use math.inf because it's guaranteed to be right. Alright, so I'm going to say for, let's check from the first one, right? For, I don't know, I, PS, enumerate pre-sum. Index shall equal to bisect right pre-sum, right? And we say PS minus X, right? PS minus X. And we say if pre-sum index minus 1 is equal to PS minus X, then res equals minimum res and I, right? I can be 0 and be 1. Yeah, what if it's the first one? First one, we need a 0. We need a 0 at front. Oof. So we need a 0 at the front. Okay. And then I can do Yeah, that'll be fine. So we have to say, hold on, let me think. We can avoid it. It's just going to be 0. If we add up to this value, it would be 0. Maybe this one's better. So that will be, yeah, it's not equal. And then it will be equal, right? And then just from this to this, whatever this value, minus 0. If it's 0, 1, 2, 2 minus, that's 2. Yeah, so it's just going to be I. Right, it's just going to be I. Yeah, so it's just going to be I. No, I'm talking about I. It's going to be I. Oh, it has to hit the first one. So actually, no. In this case, we don't need binary search at this point. Okay, we don't need binary search at this point. So all we need to do is if PS, because we have to go from left, right? Equal to X. Then res equals max, no, min res, and just gonna be I, right, from the front to this. There's the total length, the number of operations. So that's the start, right? That's the start. And else if PS is larger than X, right? Then we just break. Okay. So that's the first round. And after that, we're gonna start from the last one. Okay? We start from the last one. And we're gonna say must include. It shall be len nums. Len, no, not nums. Presum minus 1, right? That's we must include. Now in this case, do we even need a 0 at this point? I actually don't think so. Right? I don't think so. And let's not use it. And then this one just I plus 1, right? Okay. Else return minus 1. This is just sum of all elements in nums is smaller than X. Then we cannot make it. And there's also another situation is break, right? It's fine. It's fine. So we have this. Now we guarantee that the sum is going to be larger than X. Okay? Now we say must include. That's the last one. Was must include. So we're going to start from this. Okay? And we just keep popping new things in. Okay? Keep popping new things in. Now what do we say? We say for I in, shouldn't say for I. Let's just say I equals, I equals must include. That's the start. And while, that's just while true. Okay, while true. So what do? We're going to say index is going to be bisect right. Bisect right of pre-sum. That's correct. Search for x minus, not x minus. It's a pre-sum I, right? Pre-sum I minus x, right? So we're just trying to find. And we say if pre-sum index minus 1 is equal to pre-sum I minus x, so we have a match. I'll say res equals to minimum res I minus index, right? I minus index. I is the must include, index is the one. No. I minus index plus 1, because index minus 1 is the one that's the match, right? So it's this. Okay. If it's equal to, then we do this. Doesn't equal to, it's fine. Then we just say pre-sum dot append. And append a value. Okay. We append a value is pre-sum I, current one, plus what? Plus the first one. That's pre-sum I minus, we probably need n equals len nums, okay? And then this is going to be I minus n plus 1, right? Because I is n minus 1. We can actually do this way. Hold on, we move this one earlier. And this one is n. So I is n minus 1. So n minus 1 minus n plus 1 is 0. So we want to add 0 to it. So we add, pre-sum, that is not correct. That is not correct. That's not pre-sum. That's just num, right? We add this. Keep adding. We add this, and we keep adding. And when it's all done, I plus equal 1, right? We can actually, this is not while true. While what? Index. Right. We shall say if index no longer includes. So we say if index. What do you mean includes? So if index minus 1 is the match, right? Index minus 1 is the match. Hold on, let me think. Yeah, index minus 1 is going to be the match. So if index minus 1, so index minus 1 has to be smaller than must include, right? So index minus 1 is going to be the match, and the match has to be in front. If the match is larger than, then there's no point. So if this is larger or equal to, then we break, right? And then we say return minus 1 if res is larger than n, else res. All right. Moment of truth. Let's see. Honestly, this one is not that simple, but I have confidence that this logically, I think this makes sense. It makes perfect sense for me. All right, and then let's just say we can do, right, we can say delete 3 words. Oh, shoot. Okay, delete 2 words. Okay, and then we find the next one, repeat next one, repeat. Okay. And And then we have nums and x. So find array nums and x. Okay. And then do the same thing. And then back CW. This one is a min operation. So run it. Pass all 3. And let's try this. Let's see if it works. We got a wrong answer. Let's see if we can get it right. Well, it's not too big, so we'll see what happens. Answer is 16, right? Okay, so let's comment out these 3 and answer. Let's see. Pre-sum. Ooh, we didn't even hit here. Interesting. What happened? The last one. Oh, shoot. I should break here. Because we want the minimum. And then we find one and then we shall break. My bad. This is a coding error. This is purely coding error. So basically just need to break here. Try it again. Pretty good. I mean, the timing is terrible, but we got two shots. Last time we did many more shots, so I take that as a win. All right, so now the problem is, can we make it more efficient? Look at this. That's 1,000, right? So we're gonna open this one, and open this one, and kind of analyze it. So again, I firmly believe this is not an easy one. Okay, so I don't think this one is an easy one. So my previous attempt at this problem was, oh, when was that? Yeah, I don't want to see discussion. January. It was January 2021. It was quite bad. So I am genuinely, how do you spell genuinely? Glad that I am able to solve it with only one mistake. The idea is that, oh, are you saying that you don't have to do, we can just keep building, but we still need, yeah, I need a pre-sum. I need a pre-sum to do the binary search. Yeah. The idea is that oh, we don't need binary search. Lordy monstrosity, we just need a dictionary. You gotta be kidding me. We just need a dictionary. So need binary search. I see. Hold on. So we don't break. Okay, don't break. We don't break. Pre-sum dict. Right, this is going to be a dictionary. And this is going to be, oh, can we do that? Enumerate, accumulate nums, like that. If this, then we're going to be this, right? And pre-sum dict ps equals I, right? Blah, 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 once we and then we just say if what should I say? If ps is smaller than x, so at the end it's still smaller than x, then return -1. Right? So we say sum of all nums cannot match x, and then blah and blah, and then we have blah. Then we say you don't have to do this. Right? We don't have to do this. We can just say if pre-sum I, there's no pre-sum I. So we should say that's just, we have a must include, right? I equals must include, and we say current sum, right, equals ps. Oh, we'll keep using ps, which is fine. Just keep using ps, and we just say if, I don't know, ps minus x is in pre-sum dict. If it's in pre-sum dict, one can actually get it, right? One can actually get it. If it's in this dict, then what? Then we say index, right, equal to pre-sum dict ps minus x. What if it's never inside? Good point. What if it's never inside? Well, that's fine. We just keep searching, and once it's larger than this, right, because it's ps minus x, it should be something smaller than the largest. Okay, so we should do must include max sum pre-sum limit, okay, is equal to ps, and then we say if ps minus x, right, ps minus x, this is a current prefix sum, minus x, then we get this one. If this one is larger than, right, this one is, if it's equal to pre-sum limit, and it's not 0, so it's equal to pre-sum limit, then that's still not going to go. So if it's larger equal to pre-sum limit, then we're going to break, right? Otherwise, we say if this is in pre-sum dict, then we get the index, right? And oh yeah, then yeah, because then it must be smaller. Then we get the index, and we're gonna do the current index minus this index. So what we're gonna do is we can actually change this. That's gonna be ps minus x is smaller than pre-sum limit, right? If while this, then we just say, I don't know, we say res equals minimum res. We're gonna do I minus pre-sum dict dot get, right? Get what? Get ps minus x, and what's that? That will be -1. Okay. So we do that, and then what? We have the rest, and then ps need to be plus equal to nums I minus n plus 1 and I plus equal 1. That we don't have to append anything, we don't have to do anything, just like that. Name must include is not. That just be n minus 1. Ooh. Which is fine if you think about it. Basically the whole purpose is do here. Alright, and then yeah, I think it's fine. Okay, we almost got it. The second one did not write. What? 5? You gotta be kidding me. 5. 1, 2, 3, 4, 5. How'd you get this idea? There's not even 4 in there. Let's print pre-sum dict. We don't need this. We don't need this. Yep, pre-sum dict 5 is 0, 11. Yeah, that's perfect. So res is larger than n. Else res. What's n? N is numbers. 2, 3, 4, 5. Wait, we have res? What? Oh, shoot. Yeah. Gotcha. This is a little bug. Alright, I think this one will be faster. And we keep writing, right? The idea is that we produce a prefix sum, right? We produce a prefix sum on nums. This can tell us whether we can add up some values on the left to reach x. If we can, we record the length. If then we mentally append the entire array to the right, and keep doing the prefix sum, except this time we must to the right. Now we start from the let's do it again. The idea is that we produce a prefix sum on nums. Tell us whether, yeah, this is fine. Then we mentally append the entire array to the right. Let's call the new array, new nums, okay? We must start and let n equals len nums. So now we must start from new nums and it's hard to explain in words. Flip entire to the right and then continue the prefix sum. This gives us a new pre-sum that is twice the length of nums. Say n equals len nums. All right. Now we need to start from new pre-sum n minus 1, right? And going to the right. Each time we compute new pre-sum I minus x and see if this value is in any of the values to the left in new pre-sum. Right? If it is, then we have found another valid way, a valid sets of operations to reach x. Right. Continue to do this until we have gone beyond new pre-sum n minus 1. Now in implementation, we can definitely do the flip, right? We can definitely do the flip, not do the flip, I can definitely do the append and use binary search, right? Binary search to locate the target, to find whether new pre-sum I minus x is in the new pre-sum array. However, this is not necessary, right? Because each value in pre-sum is unique, which means we can use a index dict to match value to its index. So with this, we can search for the index of new pre-sum I minus 1 in O1 time. Yeah, that is basically the trick. And this one running ON, right? This is ON. This is ON, and the rest is also ON. So we can try this. Okay, I'm pretty sure this one will score a lot better. Come on. Okay. It's not a lot better. It's about the same. I mean, I don't understand. How is this only slightly better? It doesn't make any sense. All right, how about we add some more checks? More easy checks. You can say if nums 0 is larger than x, or and nums minus 1 is larger than x, then return minus 1, right? That can avoid going through this. Let's see if it's make it a little bit better. Oh, see? Well, it's a little bit more check immediately. Immediately. Reduce. This is good. So just a little bit check. Sanity check. I must have a test case like that. Alright, so this one's faster. This is good. This is acceptable. 8%, no. 77, this is acceptable. Alright, let's just see. Did they add more test cases? Yes, they did. They add more test cases. 93 this time. But this is a bad one. Previous is 88. So target is sum everything minus x. We have a dict. That's a good one. Alright, so enumerate. Yeah, this is just cumulative sum. If cumulative sum minus target. Hold on, the target is different. Target is the sum of this minus x. So if cumulative sum minus target, so cumulative sum minus sum plus x, right? So it's cumulative sum minus the sum plus x, which is equivalent to what? Cumulative sum. And then there's the full sum. So it's just like x minus full sum minus cumulative sum. So full sum minus cumulative sum is this one, right? And then we say x minus this one. X minus this one. Oh, there's some mental gymnastics I have to do. I think we're close. I think we're using the same method, but this one definitely looks better. So target is the full sum minus x, right? It doesn't really matter. and then we do cumulative sum. So we find a certain cumulative sum, right? And then we minus this target. We say if this one is inside, then I minus CS minus target. Hold on. So we have cumulative sum minus the full sum minus x. Right? We say if this is in the dictionary, which is previous cumulative, then so basically we say CS minus this. Which is just hold on. I can't make sense of it. If CS minus target is in the dictionary, which means CS minus target. So CS minus this. So this one equals target. Okay? So we say this thing is equals target. And target is total sum minus x. Because the front and the back added together equal to x. So the things in the middle must be sum minus x. So that is a target. So we just, good solution. Good solution. Right? So we just find in the middle. Now what we want is the middle to be as big as possible. Let's record the solution. It's a good one. So this is the official. So this is the official solution recorded by myself in the previous attempt at this problem. The ideal is that it's generally, I would call it generally the same, but it has a smarter and simpler implementation. All right, so let's see this one. So when I say smarter and simpler, this is what I mean. What they do is they have a dictionary, which we can call it pre-sum dict. We do the same thing, right? We have a pre-sum dict, and then they say 0 is minus 1. That's a good touch. And what else? And they have a target. So target is sum nums minus x. Right. So let me write a little bit more here. So if some values at the front and back add up to x, that means the values in the middle, right? The values in the middle must add up to sum nums minus x. So our goal is to use prefix sum to find which range of nums, right? Which range of nums adds up to sum nums minus x, right? Just which range it adds up to. And we want the largest range so that the length of the front and back is minimized, right? So that's basically the idea. So we have target, we have this, then we have prefix sum. Let's call it prefix sum is equal to 0, right? And we just say for in enumerate nums. Okay, and say ps plus equal to n. Right. So as the prefix sum, and then we say if ps, right, minus target is in pre-sum dict, then rest of the result. No. Yes, we can do result. We can. Just math.inf. We just need to have a length. Okay, so we have also n len nums. Right. So we say if it's in there, right, then we say res equals minimum res I minus pre-sum dict ps minus target. So this minus this give us the length, and we need to say n minus this, of course, plus this, right? So we just run this, blah blah blah. And then we just say return res if res is smaller or equal to n, else minus 1. Let's see, solution number 2 cannot handle something is not right. Sum minus x, okay? And then what? And then this is fine. These are all fine. Oh, I did not. Hold on. We need to do pre-sum dict ps equal to I. Yeah, we're gonna do it here. Okay, so we're gonna do the same trick if nums 0 is larger than x and nums minus 1 is larger than x, then we simply return minus 1. Okay, make things easier. That's the same solution as this one. Almost the same. Okay, almost the same. Let's try solution 2. Run it. Let's see how fast. It's all right. It's all right. Okay. Yeah, it's not an easy problem. It took us 58. That will be it. That will be it. Don't have much more capacity, so I'll just shut it down right here, and I'll see you guys tomorrow. Adios.